Okay, hopefully review for most of you. I think there are some newbies, I guess you'd say, in physics this year that maybe haven't worked with significant figures before. I just want to start off with determining, if I give you a measurement or a number, like how many sig figs are in that number. Okay. So a significant figure is a premise that relates to like measuring things in the real world. Okay. How accurate, precise, or how valid of a measurement are you making? If you have a, basically how accurate, how precise your measuring device is. We'll talk more about it in class. I'll have to explain it quite a bit. It's kind of a hard concept, but it's very important in science. It really is. But so starting off, any number, I got 1493. Okay, it could be inches, pounds, feet. It could be anything, any measurement. Any non-zero digit is significant. Okay, so there's 4 digits. None of them are 0. That means there's 4 sig figs. Okay. If I have 2, 3, 8, 3 sig figs. All right, pretty simple. Zeros in this position are not significant. Okay, this would only be 1 significant figure. However, zeros in between non-zeros, okay, the 0 is in between these, all those are significant. Okay, because these ones are significant, this one's in between, it's significant too. Okay, it kind of has to do with like rounding. Like if you make this measurement, where do you round at? We round here, we round here. On this one, we would round here, right? We rounded to 200. Those are zeros, we rounded to 200. 1, 2, 3, 4. 1, 2, 3, 1. If we rounded here on this one, 1, 2, 3, that's why it's significant. It has to do with rounding and what you know. I like to, jokingly say, what you know for show. Okay, we know these digits for show. We're trying to figure out, are we rounded on that one? We're not 100% there. Know for show, rounded, rounded, rounded. Okay. Now, when you have a decimal, okay, these zeros are not significant. All right, we rounded here, but these are just placeholders. Okay, there's actually only 2 sig figs there. Okay, if you change that to scientific notation, for example, it's 5.3 times 10 to the negative 1, 2, 3. But there's only 2 digits here. It's 2 sig figs. Okay, these ones are not significant. The only time they are is if they are to the right of the decimal, but also right of something significant. Okay, these are right of the decimal, but they're not right of anything significant over here. These ones, however, are. Okay, and this is kind of the confusing one, right? Because there's actually 4 sig figs there. Okay. Anything non-zero, significant. Zeros like that, where they're to the left of the decimal, are not significant. If they're in between, yes. To the right of the decimal, no, unless they're also to the right of something significant like that. And we'll do a lot of practice with these. A couple other ones, I guess. So if you have something like 10.00, that's actually 4 sig figs. These ones are right of the decimal and right of something significant. That means we rounded there. Whereas 10 is just 1. We rounded there. See, this says that we know 10.0, and then we're guessing here. This says we're guessing right here. This could be a 9.8, 10.2, something like that. This is 10.0, 03, 10.999. We rounded to this. It's much more accurate than this one. Yeah.